I want to introduce one just idea of this Indo-Pacific tripole, but just let's run through the composites first. So this is for the positive IOD or the Indian Ocean dipole. In June, you can begin to see some activity. These are the composite Sst anomalies, and the this part, the maritime continent part, actually should not be ignored, because now there is plenty of evidence that the rainfall anomalies here in May itself begin to influence this region, especially in terms of alongshore winds, the subsidence, the Rossby wave, and upwelling favorable winds, and so on. But nonetheless, we have kind of said that the West Pacific warm pool has this divergent flow which has global reach, tropical, extratropical connections, extratropical, tropical connections, and yet we are dealing with Indian Ocean dipole here as if it's an independent Indian Ocean mode. Not completely, but essentially the relations are not tackled in this book. But there is a lot of literature now that talks about how the Indian Ocean impacts the Pacific, even in terms of the evolution of El Nino, and how a cooling here can make an El Nino stronger, and so on and so forth, and how predictability of El Nino may come from the Indian Ocean, etc. So let's see that in a minute, but right now you can see June, July evolution is really in this region, which is critical and not explained very well in our discussion thus far. August, September, and then October, November, you can see that the cooling has peaked and disappeared. The warming on this side begins to take off, and then by December you have essentially a basin-wide warming, and then that dissipates into next May. So these are just shown as composites, but honestly most of the action happens here in these months, and there is some evidence that the process may be initiated by air-sea interactions on this side related to the precipitation variability on this side, which itself could be related to this West Pacific maritime continent convection complex, which is often referred to as the boiler box, and so on and so forth, which has huge amounts of rain. The negative IODs is when there is a warming in the east and cooling in the west, so that also has an evolution in the same region, expands out into the southeastern Indian Ocean, grows in amplitude, and then you can see that the pattern is not exactly a dipole. This is why there is a debate, and then the event disappears, and then you get monopole across the Indian Ocean. So this debate will go on. Many unanswered questions about the dynamics and thermodynamics, and of course El Nino is studied for so long with so much data, and we haven't answered many questions, so you can imagine that this is going to take some time. This is the idea of evolution of the 97-98 event from this Webster et al. Paper from 1999, which talks about the beginning of the alongshore winds, which I said is potentially related to the Indonesian rainfall anomaly over here, and then associated with that there is a thermocline signature in the ocean that grows into this easterly wind anomalies, convection on this side, and then a stronger east-west tilt of the thermocline, like in the Pacific, except that it's in the opposite sense, and then you have all these nice Ekman processes that begin to turn the process around, and by the boreal summer of 98, it's not clear the life cycle is really that long. It seems like things disappear by December of 1997 itself. So September, October, November of 97, the cooling is peaked, and then December 97, the basin-wide warming is already in place, which is very similar to what you expect in the Indian Ocean during El Nino years as a teleconnection. And then there is something called the Indo-Pacific capacitor, where the delayed warming over the Indian Ocean has an impact back on the Pacific and so on. Leaving that as it is, I know I kind of rushed through it because I think that story is given a lot of space in the book, but a lot of the new literature is not included. So the idea from Dak Chen, which has been proposed, is that there is actually something like a tripole in the Indian Ocean. So these really depends on how you analyze. We have looked at El Nino and talked about Nino 3.4, Nino 4, Nino 3, and so on. But you do the analysis over the Indo-Pacific, then you get a better sense that the Indo-Pacific warm pool has a coherent anomaly here with the divergence around the maritime continent, and the Indian Ocean response is like the dipole, which we have been looking at just as an Indian Ocean phenomenon. So that's in SST and winds, and this is in sea surface height and winds. Again, you see all kinds of signatures that are consistent with the El Nino here and the Indian Ocean dipole here. And if you do the normalized PC, these are the empirical orthogonal functions, and if you look at the time series or the principal component associated with that, you do get the El Ninos, and you get the IODs and so on. So is it that the Indian Ocean is basically a close partner of the Pacific Ocean and that they are really not able to vary so independently? It's this big heat source that can force both oceans more directly here through the oceanic tunnel, the Kelvin waves, and the thermocline signal, the delayed oscillator, recharge, discharge, and so on. Whereas on this side, it's a combination of the atmospheric bridge with the subsidence on this side, Rossby waves, alongshore winds, and maybe an oceanic tunnel through the so-called Indonesian through flow, which we haven't talked about much. So this is really an open question. So in the end, it may turn out that the strong influence of the Indian Ocean on the Pacific and the IOD may be part of this kind of Indo-Pacific tripole. And Dak Chen kind of puts it in this perspective, where he says the Pacific is the big gear and the Indian Ocean is the small gear. So the big driver is controlling most of the time, but sometimes the Indian Ocean is able to be the driver. So this may also explain why 50% of the wet and dry years are not really explained by El Ninos and La Ninas, because considering that the monsoon itself is a big heat source as well, we have to understand how it is that the interactive system of the monsoon and so Indian Ocean, etc., can work together. So this is something that I would consider somewhat of a open question that needs some new ideas, because we are basically struggling with the older ideas. Just to close out the chapter, then, the Atlantic Ocean also has something like an El Nino mode. It's called the Atlantic Zonal mode or the Atlantic Nino, and this is showing the pattern and time evolution of the interannual sea surface temperature variability in the tropical Atlantic from the NOAA data. And this is the region which gets warm. It doesn't have as much of a strong zonal contrast as the Pacific, and the zonal extent is small, so the wave travel times are small. And because of this Gulf of Guinea here, the upwelling signal is also a little bit different than the cold tongue in the Pacific. And because the ITCZ is sitting across like this, and in the boreal spring ends up touching the equator, there is a strong relation between the meridional mode of variability and the zonal mode of variability. But nonetheless, when you look at the composites, you get a sense that they are pretty close to each other. So here you are seeing, principal component of the first EOF of and SST anomalies. So they both are highly correlated, as you can expect. There is an Atlantic 3 region where SST anomalies are created, like the Nino 3 index. This is called the ATL3 index, and this is the seasonal cycle of the ATL3 box and standard deviation of the interannual anomaly. So you can see that when the summer months come, the seasonal cycle of the Atlantic SST gets weak, but the variability goes up. So whereas the Indian Ocean dipole peaks in September, October, November, the Atlantic Nino 3 is peaking in July, August, September, and that has a impact on the monsoon. So maybe some of the unexplained or non-El Nino droughts and non-La Nina floods may be related to the cold and warm events in the Atlantic Ocean. There is a lot of literature on the Atlantic Nino as well, which we haven't gone through, but there are some commonalities in the processes: recharge, discharge, Bieknes feedback, and so on. So if I have to give you one point of view, it would be that the Indonesian region and the West Pacific warm pool generally has a huge heat source in terms of that convection, and when that jiggles, it can set off these zonal disturbances, and maybe all the eastern ocean responses in the Atlantic, Indian, and the Pacific are related somehow to this forcing, but this is just something that has to be tested. But at least you know that in terms of low frequency, large scale circulations, these zonal modes of variability in each ocean are there. How they are linked to each other or whether they are really independent and so on are still very much open questions, but there are common processes in all of them. Okay, let's leave the chapter here and then move on to the next chapter.